Just a little note here. We often talk about p-values, and we might think those are measuring the effect size. But in actuality, they're measuring the sample size usually. You don't want to get confused. I'll go through some quick examples to remind you. We'd like to believe that we'd get clear results from our statistical test. The comic XKCD, the favorite cartoon of us geeks, has exactly this. Shows the famous graph about vaccine usefulness, plotting cases of COVID against time. There's the group that got the vaccine. There's the group that did not get the vaccine, instead got a placebo. And the two groups, whoosh, completely diverged. The tagline is there. We reject the null hypothesis based on hot damn, check this out. It would be nice if we had more results like that from the world, but unfortunately we do not. But that's the power of statistics, to extract sense from the noise of the world. Now, actually, this, despite the title, is not really a statistics-free representation. There's quite a bit of good work beforehand, like pre-registering the data collection, where the researchers said this is what we're going to be measuring even before the study. But commonly in statistics, we're going to get a p-value below some chosen critical value, 5% for example. We might believe that such a p-value signals a case like the two distributions I've shown here. These two distributions are completely different, really far apart. With a sample size of just 4, I can distinguish a difference in means this size at a p-value of 5%. Just 4 observations. I can certainly see some huge effect sizes. But more commonly, we don't have 4 observations and a huge effect. Instead, might have a p-value of 5% with like 100 observations. In that case, I can distinguish much smaller differences. These are standard normal distributions. You can see the plus or minus 2 standard errors on the little X ticks marks there. With more observations, you can distinguish really small difference. Here I have 10,000 observations, and oh my goodness, is there a difference? Maybe if you squint really hard, put your nose up against the computer screen, you might see the difference there, but it's really small. That's a reminder of the power of statistics, but also a reminder of the limitations of the power of statistics. A nice low p-value does not necessarily mean there's a big honking difference. It might mean there was a pretty small difference. Lots of companies do A/B tests where they put almost the same web page in front of different consumers and try to see if they make different choices. But a popular website, it's easy to generate tons and tons of observations. So a p-value of 5% to demonstrate that people prefer one layout or another, those are some incredibly tiny differences, which might not be important in the real world. That's always a separate question. Are the differences important? A p-value does not tell you that these are important differences. Rather, it tells you that we can distinguish some differences. In the world, p-values are used and abused. If you want to play with these yourself, this is the R code. You can play with these in the privacy of your own home.